We have seen previously that the thermal expansion of liquids and gases is used to measure temperature by calibrating thermometer. In this section, we will discuss briefly the application of the thermal expansion of solid. In all these applications, a bimetallic strip is used. A bimetallic strip is described below. Take two strips of dissimilar metals and weld them together. The strips in this form are said to form a bimetallic strip. When such a strip is heated, bending takes place because one strip expands more than the other. For example, brass expands more than iron, and so they can form a bimetallic strip as shown below. There are many applications in which bimetallic strips are used. They are described briefly. This thermometer consists of a bimetallic strip in the form of long spiral. Its one end is fixed and the other end is firmly joined to a pointer which moves over a scale which is calibrated to measure temperature. When the temperature rises, the spiral turnings are more tightened because of the different amount of expansion of the strips forming the giving bimetallic strips. The result in the movement of the pointer on the calibrated scale which reads the temperature directly. The above details are shown in the figure. I b- a bimetallic strip can be incorporated to an electrical circuit to serve as a thermostat, a device to control the temperature. Suppose that a bimetallic strip is connected to an electric room heater. When the current flows through the heating element of the heater, its temperature rises and attains a value at which the bending of the bimetallic strip is so large that the electric contact is broken and the current ceases to flow. This results in the fall of temperature which reaches such a value that the bimetallic strip straightens to close the circuit again. The heating element is switched on and the bending of the bimetallic strip starts again. The process of on and off is repeated and the temperature is controlled. That is temperature range of heater is fixed. A very useful application of bimetallic strip is a fire alarm. One end of the bimetallic strip is fixed and the other is free. A 6-volt battery is connected between a metallic contact and the fixed end of the bimetallic strip. Through an electric bulb or an electric bell, the metallic contact is kept just above the free end of the bimetallic strip. All the details are shown in the figure. When fire takes place, temperature rises, the bimetallic strip bends and touches the metallic contact. As a result, current begins to flow in the circuit, due to which the bulb glows or the bell begins to ring, giving an alarming signal for fire. When water is heated from 0 degree to 4 degree, it contracts continuously instead of expanding. Conversely, expand when cooled down from 4 degree to 0 degree. This expansion of water from 4 to 0 degree is called anomalous expansion. When heated from 4 to 100 degrees expansion is normal like the expansion of other liquids. Since water contracts when heated from 0 to 4 degree and expands from 4 to 100 degree, its volume is the smallest and the density is maximum at 4 degree. Hence water is heaviest at 4 degree. The normal and anomalous behavior of water with temperature is demonstrated by an experiment called Hope's experiment as described and explained below. A long metal cylinder is taken. It carries circular through around. It is the middle. Two thermometers are inserted, one near the top of the other near the bottom of the cylinder as shown in the figure. The cylinder is filled with the water varies. The the throw carries a freezing mixture of salt and water. First, the water at the middle section of cylinder starts cooling. During the cooling process, water contracts and being denser falls to the bottom. As the process of cooling falls, the temperature continues. More and more water falls to the bottom. The process of cooling and falling of water continues till the temperature of the lower half of water in the cylinder reaches 4 degree as shown by the thermometer. Thus, the temperature in the lower half at 4 degree and that in the upper half is above 4 degree as shown by the thermometer. Further fall of temperature and flowing down of water stop. Instead, instead the temperature of the upper half begins to fall because of flow of heat from upper half towards the middle section caused by the difference of temperature. The process of flow of heat continues till the temperature of whole water in the cylinder attains the same temperature of 4 degree as shown by the thermometers. Now the temperature of water at the middle of the cylinder begins to fall below 4 degree and expands. Being lighter, it goes up, and so the temperature at top begins to fall. The process of falling of the temperature and going up of water continues till the temperature of whole of the upper half cools down to 0 degree. It is indicated by thermometer. Thus, regards temperature, the water in the cylinder is divided into two distinct parts, one upper half with thermometer temperature 0 degree and the other lower half with the temperature 4 degree. The normal anomalous behavior of water with temperature is also clear from the time temp graph. Anomalous expansion of water is a blessing from God to marine life in cold areas like those situated near the poles of the earth. Temperature of water in ponds, lakes and oceans it starts falling and goes down to 4 degree in the first phase in winter season. When the temperature of water on the surface falls below 4 degree, it expands and thus being lighter, it does not sink down. Thus, the temperature of water at the surface cools down to 0 degree or below, forming ice. But under the ice, there is dense water at 4 degree. This helps in serving the precious life aquatic animals. In winter season, the water supply pipes open. The atmosphere often burst when the temperature of the surrounding falls below 4 degree. This is due to the fact that the water below 4 degree expand. Anomalous expansion that exerts pressure to the walls of the pipes and thus causes damage to it. In rainy season, a lot of water sweeps through numerous cracks and fissures in rocks. In winter season, when temperature falls below 4 degree, going down to 0 degree or below, expansion of water take place, thus developing a high pressure. This results in the breaking of the rocks.